Okay, let's finish off this problem, and this is where we're really going to show off where Excel is really nice because we're going to do a bajillion different equations at once. And so once again, I want to build up this first row, this first column, and then we're just going to drag it over so we don't have to do each one individually. So the first thing I want to do is I want to count the sample size for 1 and the sample size for 2. So this is where I'm going to use my count ifs. And so I'm going to count all of the locations that are location 1. And so there we go. Done. So 129, I want to do the same thing for 2. Since I've got that range name in there, we can just drag that down to get 123. So now we're going to do the sample mean for 1 and the sample mean for 2. So how are we going to do that? We're going to go to our average if. We're going to build the same start part of the equation. The location is the range. What we're going to be looking for is we're going to be looking for 1. And I'm going to lock the row in because we're going to be dragging these all over the place. And so then the range I want to average is total income. Close that up. And so 73,000. We will drag that down for the second one. And we'll take a look at it. And so we want to go to N23 because we want the next one. Okay, so now we look at that. Everything's the way it should be. And let's see, we want to do the sample difference. This one's easy. It's just going to be 2 minus 1. And so there we go, 17,000. And so, oh, I'm sorry, 1 minus 2. I did 2 minus 1. Let's 1 minus 2. It's still a difference. It's in what direction. So we want to know that sample 1 is 17,000 less than sample 2. Okay, now here we go. We're going into our standard deviation. Once again, there's no standard deviation if. We're going to use that array function. So stdev.s for the sample, and then we're going to start our if function. And so that's going to be if. And so the logical test will be the location. So if the location is equal to N22, and we're going to, let's see, I don't want to put the $sign all in there because I want that to freely float. That was the mistake I made with the last one. So if that location is equal to location 1, or N22, then what I want to do is I want to do the standard deviation of the total income. And so there we go. Now remember, Control-Shift-Enter. We found a typo. What did I do? I did not put in enough parentheses. I need that second one. Yes, you can add that second parentheses. So 28509. So that is good. It is an array function. There are my bars. I'm going to take this, I'm going to drag this down because array functions, fortunately, are draggable. So standard deviation of 2. Notice it dragged down our bracket. So we have our array functions. Everything's going well. And so now let's do our standard deviation, our pooled standard deviation. So our pooled standard deviation is going to be, wait a second. Need to grab something. The wonders of being home with children. So I want to do my pooled standard deviation. So here we go. We got that messy equation that we're going to write. So I have the square root, and I will preload those in. So I've got the square root of sample size 1 minus 1 to give us our degrees of freedom. I'm going to multiply that by the standard deviation of sample 1. I'm going to square that. So I have my degrees of freedom times the square of my standard deviation. And then I'm going to add to that everything from sample 2. So 25 minus 1. I will put parentheses around that. and multiply that by my standard deviation of 2, which we will then square. Okay, so that's the upper part, the numerator of my equation. Close that red set of parentheses, and then I'm going to divide that by my degrees of freedom. My degree of freedom, how do I calculate that? It's going to be sample size 1 plus sample size 2. We have 2 sets of samples, so minus 2 for my degrees of freedom. My denominator set, I will close everything out so to get the one big huge square root, and I'm going to hit enter and hope it works. And so my pooled standard deviation of 29,847 looks good. And so now we need to do the standard error of the difference. So standard error, we're going to take the pooled standard deviation, and then I'm going to multiply that by the square root of the sum of the inverses of my sample size. So 1 divided by sample size 1 plus 1 divided by sample size 2. Divide happens before plus, that's why I'm not worried about any parentheses or anything in there. Okay, standard error of the difference, 3,761. So the last two things to do is to calculate out our T alpha value and calculate out the number of degrees of freedom. So degrees of freedom is just going to be my sample size plus my second sample size minus 2. So we have 250 degrees of freedom. And so now we will go and we will calculate out my T value. And so once again, we are going to be using the T inverse function because we want an actual value. So T inverse two-tailed because we want to make sure that we get both sides of our probability distribution. And as usual, we want to make sure that we actually finish the equation. So we hit tab. So my confidence interval is 90. So I'm going to use my alpha value, 1 minus my confidence interval. That gives me a 10% alpha. And then I need my degrees of freedom, which is 250. And so we go and we finish that up. We get a T value of 1.65. Okay, and so the last thing that we need to do is let's put together our confidence interval, our upper and our lower limit. So N28, that's our difference. And we're going to lock in the row. We're going to let the columns float. Where's my ampersand? Not ampersand, dollar sign. Okay, and from there, we're going to do a plus or minus. So we're going to minus our T value. And once again, we're going to lock in the row because we're going to drag stuff around. So I've got my T value, and then I'm going to multiply it by the standard error of the difference. And once again, we will put a dollar sign in there. Okay, negative 23,000. Then we'll drag that to the upper limit. And then we'll change the minus to the plus. And so there we go. 90% of those 90% confidence that the difference is going to be between negative 23,000 and negative 10,000. So that means the people in location 1 are going to be making less than the people in location 2. So we have this all done. We should have it all set. We're just going to drag it all over, including those array equations. We're going to hope that it all works just fine. And so just randomly taking a look at a couple of them, it looks like everything filled in exactly the way that we wanted it to. Everything rolled right. Those numbers all look good. And that's a lot of statistics that have just been done within the 2 seconds of dragging things over. Okay, so the last thing it was asking us is what conclusions can we draw from the income. So as I go and I look at how it compares to everything, it looks like number-wise, L2 is the highest value, is the highest income by location, and that's greater than, so obviously location 1's less than 2, but on average it's higher than 3 or 4, so that means L1 would be the next. And so the last thing that we have is we just have to look between the difference of L3 and L4. And so we did calculate out 3 and 4. 3 is bigger than 4, so that's L3. And so L4, location 4, which would be I think the southwest side of the city. I actually don't remember because we just we locked that in. So the most expensive part of the city, or not the most expensive part of the city, sorry. The highest income part of the city is L2, followed by 1, followed by 3, followed by 4. And all of these are at a 90% confidence interval. So we're 90% confident that those numbers are going to fall in between those ranges. Now I do have this set up in the arrays, which is nice because if I go, hey, I want to do a 95% confidence interval, I can just sit there and I can tighten things up and I can see where I would be with a 95% interval. And also with this, the way this is set up, we can easily start comparing other locations just by dragging it over. So it's all set, it's all ready to go, everything's beautiful. And so that is the end of the problem. If you have any questions, please let me know and I will answer them. Otherwise, I will see you at the next example. And instead of canceling that, I need to end the recording.